A cell's function consists of many different reactions. One reaction will be monomers, which consists of lipids, proteins, nucleic acids, and carbohydrates covalently bonded together to form a polymer. An example of that would be a phospholipid. A phospholipid is a molecule that consists of two fatty acids and a phosphate group that is bonded to a glycerol. That type of bond we call a ester linkage, um, which is why phospholipid is critical for all existing cells. So now that we have our phospholipid that is covalently bonded and ester link, these bonds can also be broken apart by a reaction called dehydration. Dehydration is when we add our H2O, and that is when we're going to link that to our molecule, and that is going to break the molecule apart to not have it stick together so strongly. And that is what we call the reaction dehydration and the breaking apart of our phospholipids.
Today I'll be talking about fat. Fat are not polymer. They are the larger molecule assembled from smaller molecule by dehydration reaction. They usually form from two kind of smaller molecules, which are called glycerol and fatty acid. Glycerol are alcohol and they are from the hydroxy group, while the fatty acid are from the carboxy group. When these two forms together, the glycerol and the fatty acid, their resulting fat is triglycerol, which brings about the saturated and unsaturated fat. And this saturated and unsaturated fat, they are commonly used in the context of nutrition. And today, I'll be making my demonstration on saturated fatty acid and unsaturated fatty acid. I have two examples which I'm going to use for my demonstration. The one is vegetable oil, and the second one is my butter. Both are left on the at room temperature for more than 30 minutes. And as we can see, this is the example of the saturated fatty acid. The molecules in this saturated fatty acid, they are closely packed together because of the presence of the single bond, the absence of double bond. That is why the molecule right here, they are closely packed. They find it so difficult to break apart. I even tried to flip it around to see if it's going to if it's going to to come out of the pack, but it's not because they are you know the bond in between them are so strong. They are closely packed together. That is why they solidify and they are not ready to let go of each other. And here I have my vegetable oil, which is the example of unsaturated fatty acid, which was left at room temperature for the same amount of time with the same example I use for saturated fatty acid. We can see these are loosely packed, and that's because of the presence of double bond. They lack that of single bond. That is why we can see them, you know, unable to solidify even at room temperature.